So in this video today, we're going to talk about factoring. We're going to talk about greatest common factors, sum and difference of two perfect squares, and the sum and difference of cubes. So first question here is, what does it mean to factor? Factoring means that we're writing something as a product. So in the last unit, we were talking about how we multiplied two binomials together. Now we're going to figure out, and we got a product. Now we're going to look at that product and figure out what the two factors are, or the factors, because there may be more than two. So first here it says always look for the greatest common factor first. Okay, that's always going to be our goal. That's going to be the first thing we're going to do every time. So here, greatest common factor, what does that mean? That means the biggest number that is a factor of all the terms. So we've got 32, 16, and 40 here. Well, we could say 2 is, right? Because 2 goes into all three of those. Also, 4 goes into 32 8 times. 4 into 16 is 4. 4 into 40 is 10. But let's see if there's a bigger one. So what about if we divide all of them by 8? 8 into 32 is 4. 8 into 16 is 2. 8 into 40 is 5. So yeah, I think the number is 8. I would go ahead and try 16 because I know that 16 goes into 32, but 16 does not go evenly into 40. So if we look at our GCF for example 1, it's going to be 8. Then when we look at example 2, we want to see what is the biggest term that is actually in every single one of those expressions. So we've got an x in all three and only an x to the first. We've got an x to the second in the middle term, but it's not in all of them. So we can write x. Then we've also got a y to the first in all three of them. We got a y to the second in the middle one and a y to the third, but the biggest term that's in all is just a y. And then if we look at z, we've got a z to the second in the first one, a z to the second in the second one, but in the last one we've only got a z. So again, the biggest term that's in all three is just a z. All right, then down here, this term on y'all's paper is a 3, not a 35. So I'm going to go ahead and scratch through that because sometimes this is going to happen. All right, so is there a GCF of 103? No, there's not. Now, if it was 35, it would have been 5, right? But on y'all's paper, it has 100x plus 3. So this has no GCF, okay, or none. We could say none here. So this should be our process, okay? So we're going to factor two terms. So always look for a GCF first. That's always going to be our case. We're always going to look for a GCF first. Then we're going to look for a special pattern. So today we're going to talk about sum and difference of squares, and we're going to talk about the sum and difference of cubes. First, let's talk about what a perfect square is. So if we square the 1 squared is 1. If we square the 2, that's 4. Same way, I'm just going to keep going down through here and doing these. So you guys can do these on your calculator. It's very helpful to know what these are, and most of you do. But if you don't, sorry, what did I do there? If you don't, then what you need to do is you need to write these down so that you have them in your head. What are perfect squares? So what we're doing with all of these terms is we're squaring those numbers. And then we're writing down what the squares of each of these are. Now, I would hope most of y'all would know at least 1 through 10. But again, you'll have these on your sheet of paper, so it's pretty easy to look at. And you'll also be able to do this in a calculator if you need to. So those are all our perfect squares there. When we square each of those numbers, that's what we get. So here's our rule. So when we're looking at the difference of two perfect squares, we have a square here as a squared, and we have a square as b. There's always going to be a subtraction sign between them. So when we do this, we're going to take the square root of a squared. That would give us a, right? We're going to take the square root of b squared. That would give us b. Those are the terms that we're going to put in parentheses, two sets of parentheses, a and b. And then when there's a minus sign between them, we're always going to put a plus and a minus between them here. So let's look at our example 4. So in example 4, the first thing we want to do, again, anytime we do these problems, is look for a GCF. So I notice immediately that both of these terms are even. So I think I can factor a 2 out of both. So I'm going to factor a 2 out first. That's going to give me 9x squared minus 25. Right now, you should notice, and you have your list up above there, that 9 is a perfect square and 25 is a perfect square. So what we're going to do now is we're going to take the square root of both of these numbers, the 9x squared, that's going to give us 3x, right? And the 25, that's going to give us 5. We're going to put those numbers along, we're going to bring our 2 down, and then we're going to put those numbers in 2 sets of parentheses. And again, because there's a minus between them, we're going to put a plus and a minus here. Because they're 2 perfect squares with a minus between them, take the square root of both, drop them in the parentheses, put a plus and minus between them. Okay, let's look at example 5 now. Again, our process, we're going to take a square root of this. There definitely is not a GCF here, okay? So in the parentheses, we're going to put a 1 and a 4y and a 1 and a 4y, again, plus and minus. So on this U-try, again, we're going to look at it and see if there's a GCF. So 3 might go into both. And you can just start dividing these numbers by numbers. 4, 5, 6. I figured out that 9 is the GCF, because if I divide 9 into 81, I get 9a squared, 81a squared. And then here I get 16. Well, you should notice right now that both of these are perfect squares. So once again, we're going to take the square root of the 9a squared and the square root of the 16. So we're going to leave our 9 out here, and we're going to write 3a and 4 and 3a and 4. We're just going to put a plus and a minus. So that is 81a squared minus 144 factored completely. So now we have an a squared plus a b squared. So once again, we have 2 perfect squares in the first position and the second position. This time, however, we have a plus sign between them. And if you recall, when we have, it says here, why is there an a? Well, or an I is an imaginary number. What is I squared though? I squared equals -1. And so when we multiply this times this, guys, what are we going to end up with? We're going to end up with a b squared, a minus b squared times, so again, watch, we would end up with minus b squared I squared, right? Which would be what? Minus b squared times the -1, which would be what again? It would be plus b squared. So that's why this works here, okay? Now, to do this, we're going to do the same process we did before. We're going to take the square root of this and the square root of this. The only difference is, and we're going to put a and b and a and b. The only difference is this time, we're going to put our plus and minus. We know that there's got to be an I because there's a plus sign. And so it's going to make that, again, that negative b squared, a positive b squared. And that's why we know that there's an I, okay? So now let's work a couple problems. Let's see if I can move this thing up. All right, so here we go again. So now what we want to ask ourselves first here, is there a GCF? So does 4 go into 81? Does 2 go into 81? No and no. Okay, so here we go again. We're going to take the square root of this, and we're going to take the square root of this. So we're going to get the square root of 4 is 2. The square root of m squared is m. So this is going to be 2m and 2m. And then we take square root of 81, we get 9 and 9. And once again, remember, we're going to do our plus and our minus. And because there's a plus sign right there, we know that this is going to have an I and an I. Okay? So on the next one, example, again, we're going to look at it. They look like they're both even numbers to me. So I'm going to divide them both by 2. So if I factor out a 2, I get 2 times 49 is 98, and 2 times 16 is 32. Okay? So now I notice immediately again that I've got some perfect squares here. So that's a perfect square, the 49 is, and so is the 16z squared. So I'm going to bring my 2 down this time. Then I've got 7 and 4z, 7 and 4z. So here again, I got my plus and my minus. The only difference is because we had a plus right here, we're going to put an I here and an I here. See if you guys can do the next problem. So go ahead and do this problem, pause the video, come back to me when you're done. Okay, so I notice immediately that both of these have a factor of 3. So here again, both of these are perfect squares, right? So we're going to bring our 3 here. Then this is going to be 2x. 2x. Then we've got a 3 and a 3, right? Because square root of 9 is 3. We're going to put our plus and our minus here. And recall again, because there's a plus sign right here, we're going to put an I and an I. So that is 12x squared plus 27 factored completely. So now we're going to talk about cubes. So we're going to cube each of these numbers. So we're going to take each of these to the third power. 3 times 3 times 3 is 1. 2 times 2 times 2 is 8. And remember, you can do this in your calculator by doing caret to the third power, right? This one's 27, 64, 125. 6 to the third is 216. Now this is going to be important because being able to recognize these as you work through problems is going to be important, y'all. 7 to the third is 343. 8 to the third is 512. Again, y'all can do all these in your calculator. 9 to the third, 729. 10 to the third is 1,000. 11 to the third is 1331. And 12 to the third is 1,728. So those are all of our cubes, okay, that we would have commonly in a problem, okay? So here again, when we're looking at sum and difference of cubes, we're looking at, do we have a cube in the first position and a cube in the second position? And then we're asking ourselves, is there a plus sign or a minus sign between them? The patterns are similar, but a little bit different. So in the first one, again, if we were trying to figure this out, we could do the third root, which remember, the third root is the same thing as taking something to the 1/3 power, okay? So that's going to give us then our A and our B. And then what we're going to do for our second set of parentheses, so if there's a plus sign here, then there's going to be a plus sign here. And in our second set of parentheses, our middle term is going to be negative. Y'all notice that right there? Okay, down here for the difference of cubes, if we have a minus sign here, we're going to end up with a minus sign in the first set of parentheses and plus sign in the second set of parentheses, okay? The pattern's the same. We're going to take the cube root of whatever that number is, and then those are the numbers that we're going to put in the first set of parentheses. Then we're going to use those to work the rest of the problem, okay? So what I want you guys to notice when we work this problem is how we do it, okay? So now, because we have our table, you should be able to see that 4 to the third is 64. Now, there's a couple ways we could do this. We could know that this is 4 to the third and this is x to the third, right? So that means if we take the third root of this, this is going to be 4x, right? Then with this again, we could take the third root of 729, which means we could also do it like 729 to the 1/3 power, right? That is going to give us 9. So we have a plus sign here, so we're going to put a plus sign here, okay? So that is our first step. Now what we're going to do is take that term, that first term, that 4x, and we're going to square it. For the middle term, we're going to multiply the 4x. Now remember, the middle term is going to be negative here because there was a plus in the first we're going to put a minus in the middle term here. So we're going to do 4x times 9. And then we're going to take the 9 and we're going to square it. So when we simplify this, we're going to get 4x plus 9. When we square the 4, we get 16. And when we square the x, we get x squared. So this is going to be 16x squared. For negative 4x times 9 is going to be negative 36x. And then 9 squared is 81. So that is 6x to the third plus 729 factored. Okay, now let's do this other one over here. So over here again, we're going to take this to the 1/3 power, or you can look at your table. And what number cubed was 216? I see that it's 6, right? And then we've got, again, if we take the cube root of this, we get a, right? And then again, we're going to take the cube root of this, or take it to the 1/3 power. That's going to be minus 1, okay? Now, once again, we're going to take the 6a, and we're going to square it. This time, we're going to have a plus for the middle term because there was a minus here. There's going to be a plus there. There was a minus in the first set of parentheses because there was a minus in the original problem. Okay, then we're going to do 6a times 1, and then we're going to do 1 squared. That's going to be our second set of parentheses. So we're going to leave it 6a minus 1. 6 times 6 is 36. A times a is a squared. So this is 36a squared. 1 times anything is itself. And 1 squared is 1. So that is the factorization of 216a to the third minus 1. So I'd like you guys to go ahead and do these U tries, then come back to me when you're done. So on this first U try, I notice that 2 is a factor of both of these. So I'm going to factor the 2 out first. Now I'm going to look at this and I'm going to take the third root of both of these, right? So you can either do it this way, or again, you can do it this way. It doesn't matter which one. So I know then I've got 2 and I've got an x, right? And a minus. I did a minus because there was a minus in the original problem. And then if I take the third power, the 1/3 power of 8, I get 2. So here again, we're going to do x squared. We're going to multiply the two terms together for the middle. And this time there's going to be a plus because there was a minus in the first set of parentheses. So we're going to do x times 2. And then we're going to do plus 2 squared. So we get 2 times x minus 2 times x squared plus 2x plus 4. That is the complete factorization of 2x to the third minus 16. Now let's look at our problem over here. So I notice immediately again that 8 is a factor of both of these numbers. So I'm going to factor the 8 out first. That's going to give me 8x to the third plus y to the third. Again, we're going to take our third root of these. And again, you can either do the third root or you can do the 1/3 power. So when I do that, I still get my 8 on the outside. Then when I take the 1/3 power of 8, I get 2. And then when I take the 1/3 power of x to the third, I get x. And I get y here. So put the plus sign again because there's a plus sign there. So now we're going to take our 2x and we're going to square it. And then we're going to multiply our, wait, forget it. Sorry, y'all, I got to put the minus there. My bad, I messed up. See, even I forget sometimes. So that was 2x squared. Yeah, I don't know whether it's going to write or not. Sorry, y'all, it's lagging. Welcome to my world. All right, we'll try this again. 2x squared Then we're going to do, see, almost did it again. This has got to be a minus, y'all, because the first one was a plus. This is minus, and then we're going to multiply the 2x times the y, and then we're going to do plus y squared. So this would be 8, 2x plus y. 2 times 2 is 4, so this can be 4, and x times x is x squared, minus 2xy, and y squared is obviously y squared. Okay. So we had some practice with partners on the bottom, so I'm going to go ahead and work these for you too. So let's go ahead and do this first one, 27. So again, I'm going to take this to the 1/3 power. That's going to give me 3x, and then take this to the 1/3 power. That's going to give me minus 2. We're going to then square that. 3x squared is 9x squared. Multiply the two of them together. Remember, we're going to have a plus sign there because the first one had a minus sign. So this is going to be 6x when we multiply 3x times 2. And then 2 squared is 4. So that's that in its most simplified form. Now, we already did 2 and 3 in the notes, so I'm not going to do them again. So we're going to jump down here to 4. And again, if we take this to the 1/3 power, you should all know that that's 10. So this is going to be x minus 10. And then x times x, which is x squared, right? Then this is going to be plus 10x. And then we're going to take that 10 and square it. So this is going to be plus 100. Okay? Here's our pattern again for the next one. We take the cube root of this, we take this to the 1/3 power, right? So we're going to get a minus 3. Then we're going to square that a. We're going to multiply the two of them together. Remember, there's going to be a plus here. That's going to be 3a. And then we're going to square the 3. So that's going to be 9. All right, so this next one, I see that it has a factor of 2. I know for sure that 2 goes into both of those, so I'm going to factor out that 2 first. And then here again, taking the cube root of x to the 3rd and taking this to the 1/3 power, that would be 5. So this is going to be 2x minus 5. Going to square the x, that's x squared. Multiply the 5 times the x. Remember again, there's a plus sign there, 5x. And then we're going to square the 5, so that's going to be 25.